All right, let's do this. We have a lot to get through today. And the first thing we're going to start with is completing the square, the method of completing the square on an equation. And then we're going to complete the square on a function. So on Tuesday, we learned how to solve quadratic equations by factoring, by the square root method, and by the quadratic formula. Well, completing the square is another method to solve a quadratic equation. And in order to do the completing the square process, we need to have a perfect form. That form is going to be x squared plus bx equal to c. So in order to complete the square on an equation or a function, the leading coefficient of x squared must always be 1. And once we get this perfect format, then we can continue the method. And what we're going to do is take half of the middle term's coefficient and square it, as you see here. We take half of the middle term's coefficient and square it. After we do that, we will add that number to both sides of the equation, giving us x squared plus bx plus the number that we halved and squared, so b over 2 squared, equal to c plus b over 2 squared. So we add this number to both sides of the equation. And then after we add it to both sides, we will simplify. We'll factor the left, simplify the right, and then we will use the square root method to solve for x. Okay, so for now, let's just look for the perfect form. And if we have it, we can complete the square. So let's start with example 1. Here it says solve x squared minus 6x plus 5 equal to 0. Solve this by completing the square. Okay, well, one thing we notice is that the leading coefficient of this x squared happens to be 1. So there's a 1x squared. So that's part of the perfect form. But then, in order to get the form, the perfect form, we need to take this 5 and move it over. So we're going to rewrite this as x squared minus 6x equal to negative 5. Now this looks just like the perfect form that we need. Okay, and since it's in the perfect form, we are now going to complete the square on it. And I'll say complete the square, which means we're going to take half of the middle term's coefficient. So we're going to say negative 6 over 2 and square it. We're going to reduce it to negative 3 and then square that, and we're going to get positive 9. Now what we do with this number is, again, we add it to both sides of this equation. So I'm going to get x squared minus 6x plus the 9 we got from completing the square, and set it equal to negative 5 plus the 9 we got from completing the square. So after you complete the square, after you take the middle term, you divide it by 2 and square it, we add it to both sides. Now, once you do this process, the left side becomes factorable. So this means that we can always factor the left side. It will always be factorable no matter what after you complete the square. And this will factor to x minus 3 times x minus 3. And then, like I said, you factor the left and you simplify the right side. So negative 5 plus 9 gives me 4. Okay. And a cool little trick to factoring these is that if you have no idea what number goes in your sets of parentheses when you factor it, well, it's going to be the number that you square. Look at this. I have a negative 3. I have a negative 3. That is the same number that we squared when we were completing the square. So all you have to really do to factor these is just take this number of -3 and plug it into your parentheses. One of the fastest way to factor it. Okay. And now we must solve for x. So x minus 3, since it shows up twice, we can rewrite it as x minus 3 squared. Set it equal to 4. And now we're going to solve by using the square root method. So we're going to square root. So this uses the square root method that we learned last class. And we're going to get x minus 3 equal to plus or minus 2. Now just add the 3 over. And you'll get x equals +3 plus or minus 2. And my two answers are going to be 3 plus 2, which will give me 5, and 3 minus 2, which will give me 1. There we go. Okay, so that is how you complete the square. That is the fourth way to solve a quadratic equation. Any questions on that process? And of course, we'll do it again below.
So if we're answering or entering that for the homework, do we just do 5,1?
Exactly. So yeah, so good. So for my math lab, it's going to say x equals, and then you'll have 5, 1. There you go. Okay, let's try it again. So here we're given 9x squared plus 18x equal to 7. So let me just go ahead and rewrite this one out here. 9x squared plus 18x equal to 7. This is almost in the perfect form, except we see that we have a leading coefficient of 9. And in order to be in a perfect form, we need to have a leading coefficient of 1. Well, what's great about this being an equation is that we can manipulate it how we want, which means that if I want to get a 1 in front of that x squared, all I'm going to do is divide everything by 9. I'm going to divide everything by 9. And we're allowed to do this because it's an equation. So if I do that, I'll get x squared plus 18 divided 9, 2x equal to 7/9. Okay, and now we are in the perfect form. So now we can complete the square, and we take half of the middle term's coefficient and square it. Reduce it, then square it, and 1 squared is still 1. Okay.
So that's literally completing the square.
That's it.
And the C plus S, you're just putting that to let us know.
Oh, sorry, that's CTS. There you go. Complete the square. All right. And then you'll have x squared plus 2x plus the number we got from completing the square equal to 7/9 plus, again, the number we get from completing the square. Okay. And now factor it. Remember, the left side becomes completely factorable. So x squared plus 2x plus 1 is going to factor to x plus 1 times x plus 1. The right side, we have some work to do. You have 7/9 plus 1. Well, what I can do is change 1 into a fraction, get a common denominator of 1. So not of 1, of 9. So multiply this by 9/9, and you'll get 7/9 plus 9/9, which gives me 16/9. So that's going to go right here, 16/9. All right, clean it up some more. You get x plus 1 squared equal to 16/9, and then square root both sides. All right, that means that this will become x plus 1 equal to plus or minus, well, the square root of 16 is 4, and the square root of 9 is 3. Okay. And then
I'm kind of confused on where you're getting the 9 ninths.
9. Oh, okay. So from this part, right?
Uh-huh.
So I'm saying 7/9 plus 1. Well, if I want to add these two numbers, you have to change 1 into a fraction.
So where's the one's coming from completing the square?
Exactly. So this one comes from completing the square.
So we complete the square, then we add it to both sides.
Exactly.
And then factor and simplify.
Exactly.
Okay.
And then for that 9/9, again, you need to do 7/9 plus 1, but you have to change 1 into a fraction and get a common denominator of 9.
Sure.
And that would give you 7/9 plus 9/9, which would give you the 16/9.
Cool. Cool.
Or if you like the other fraction trick, which I like a lot better, but you have to understand fractions to get it, you say 1 times 9 is 9, and then 9 plus 7 gives you 16. Therefore, you get 16/9, which is a lot faster. But again, you have to definitely understand how to work fractions to get there. Okay. Now this means that you'll move the 1 over. So let's see. I can write that below. And you'll have x equals -1 plus or minus 4/3. Okay. And then from here, we'll do the math. So we'll have the plus route, and I'll have -1 plus 4/3, and we'll have the minus route, -1 minus 4/3. All right. Well. Like I said, if you do the fraction trick, what's -1 times 3?
-3.
-3. And what's -3 plus 4?
1.
1. So this means that you're going to get 1/3. There's your first answer. And you can do it again for below. So what's -1 times 3? -3, right? And then -3 minus 4, meaning you go more negative, you're going to get -7/3. Or we keep it the old school way and we say -1 minus 4/3. You make this one into a fraction and you get a common denominator of 3. This means that you'll get -3/3 minus 4/3, which gives you -7/3. However you want to go about handling those fractions. Okay, and that's completing the square on an equation, which is going to be helpful for your homework and for the word problems. Because if you click the Help Me button, this is the only way my math lab is going to show you. No other way. And it's also cool to know that this is the fourth way of solving quadratic equations. All right. Any questions on that page?
No, sir.
Okay. So that's completing the square in the equation. Now, let's do completing the square on a function. All right. So same rules apply here. To complete the square in a function, you still need to have a leading coefficient of 1. It's just going to be a lot trickier this time. Okay. And the reason we complete the square in a function is to put the equation or the function into a special form. So if you complete the square in a function, it puts it into a special form called vertex form. And this form is given as a times x minus h squared plus k. This is the form we will be using to graph our quadratic functions. But in order to put it in this form, we must complete the square. Okay. So again, the methods are still the same. The leading coefficient must be 1. If it's not 1, then we must factor it out to become 1. We must factor whatever number there is to become 1. And then once you do that, you can complete the square. But then instead of adding it to both sides, we're going to have to add and subtract the number on the same line. Because when you deal with a function, there's only one side. We only have one side to work with. We don't have two sides to work with like we did on an equation. So when we completed the square on an equation, we were able to add it to both sides. But now when you complete the square on a function, you must add it and subtract it on the same line. And once you do that and simplify, factor, and simplify, you will arrive at vertex form. Okay, so I'll show you how to work this. All right. So we'll skip example 3 for now because that one's a little tricky, but we'll go to example 4, which is perfect. So complete the square and find the vertex form of the quadratic function x squared minus 4x plus 17. Okay, so if you notice, this already has the perfect form. We have a leading coefficient of 1. That's perfect, which means we are all set to complete the square. So I'll just rewrite it out here. Let me see. Let me zoom in a bit. And then we'll have f of x equals x squared minus 4x plus 17. Again, we have that leading coefficient of 1. This is in the perfect form. So when we complete the square, we take half of the middle term's coefficient. So we're going to take half of negative 4 and square it. Here we'll get negative 2 squared, which is going to be 4. Okay. Now when I move to the next line, we're going to have x squared minus 4x plus, and like I said, since this is a function, you are going to add it and subtract it on the same line. So you're going to get x squared minus 4x plus 4 minus 4 plus the 17 that was there already. All right, so we add it and we subtract it on the same line. Okay, and just like an equation, the left part of this line will become factorable. You can factor this always. And this part, you will simplify. Okay, this means that we'll get f of x equals, and that x squared minus 4x plus 4 is going to become x minus 2, x minus 2. And again, if you're wondering how to factor these that fast, you just plug in whatever number you squared. So that's x minus 2, x minus 2. It's a nice trick, saves you time. And then you simplify -4 plus 17, that'll give me 13. One last simplification, you'll get f of x equals x minus 2 squared plus 13, and we have it. This is called vertex form. Okay, soak it in. I know it's a lot to handle. Something brand new you're seeing. All right, but any questions on this one? Okay, so that's our goal. We're going to be given quadratic functions, and we're going to complete the square to put it into vertex form, which is going to be a lot easier for us to graph with. Okay, now let's go to this. Oh, what's that?
I was wondering, does it matter where you place the negative or positive version of the completed square?
It does. It always has to be plus minus.
Plus minus. Okay.
If you had it as minus plus, it's not going to work out for you. So that's actually a really good question. So yeah, it's always add and subtract. Okay, now on to the tricky one. So I'll rewrite it out here. Come on, right now. There we go. F of x equals negative x squared plus 8x minus 63. Okay, so this one's almost in the perfect form, except that we notice the leading term is a -1, and it has to be a positive one. So what we're going to do here, in order to put it into the perfect form, is we are just going to factor -1 from the x terms. That's it. We don't factor it from the last term, the constant. We only factor from the x terms. Because if you think about it, on an equation, the perfect form was x squared plus bx equal to c. We never really care about the constant. We only care about the x terms. So this is what we're going for. That x squared has to have a 1 in front. So therefore, we're only going to factor -1 out from the x terms. Okay. So when I do this, I'm going to have -1 factored out. And this is going to give me positive x squared minus 8x minus 63. And now the inside x terms is in my proper form. And when I say proper form, this looks like x squared plus bx, which means from this step, we are ready to complete the square. CTS, we're going to take half of the middle term's coefficient, -8/2, and square it. Reduce to -4 squared, and we get 16. Okay. And now we're going to take that 16 and add it and subtract it on the same line. But here's where I say it's a little tricky. Because now you still have that -1 out in front, but inside you're going to have x squared minus 8x plus 16 minus 16, close parentheses, minus 63. Okay. So all of this is inside the parentheses. And some things still haven't changed. This trinomial is still going to be factorable. So we can factor this trinomial. So that's what we're going to do first. I'm going to get f of x equals -1. And I'm going to put brackets here for neatness. I'm just going to put a bracket there. X squared minus 8x plus 16 is going to factor to x minus 4 times x minus 4. And then minus that 16 that's there. Close my bracket for neatness. Okay. And now let's go ahead and clean this up one more time to write it a little neater. I'm still going to keep those brackets there. X minus 4 times x minus 4 is x minus 4 squared minus 16 minus the 63. Okay, so what we're going to do now is take this -1 and distribute it. So we're going to take this -1 and distribute it to both terms inside my brackets. I'm going to end up with f of x equals -1 times x minus 4 squared plus 16 minus 63. And all I have to do now is simplify these two terms and we're done. We get f of x equals -x minus 4 squared minus whatever 16 minus 63 is.
So you distribute the 1, but you leave the negative sign?
Well, you distribute the -1.
Then why is x -4 stayed the same?
Because you can't distribute it inside the parentheses. You're multiplying the whole thing by it. So okay. You see, that's why that -1's still outside.
Yeah, all right.
We cannot distribute it in there because of that power.
Okay.
No, valid question. That's good. Good questions. Okay, and 16 minus 63 is 47. And there it is. There's the vertex form. That's why I didn't want to start off with this one. Yeah, so let's say I had something set up like 2 times x plus 1 plus 2, something written like this. And if I distributed the 2, I wouldn't distribute the 2 inside the x plus 1 yet. I would first rewrite it as 2 times x plus 1 plus 4.
And that's true when you're dealing with double brackets always.
Exactly. Well, I mean, I use brackets for neatness. This could be parentheses if it wanted to be.
Mm-hmm.
But either way, you multiply that 2. And then if there's no power here other than 1, you can distribute that 2 in there. But if this is x plus 1 squared or cubed or to whatever power, like to the 5th, you cannot multiply that 2 in there.
10-4.
Okay. And that's completing the square on functions and equations. Whew. All right. Now we can get into graphing these. All right. But any questions on this before moving on?
No, sir.
All right. Okay. Now we get into the properties of quadratic functions and their graphs. So we have been factoring quadratic functions. We've learned about functions, and a quadratic function is the form of ax squared plus bx plus c. Well, the graph that matches a quadratic function is called a parabola. And depending on the leading coefficient of a quadratic function, that will determine how your graph looks. So if we look at the first graph here, if the leading coefficient of a quadratic function is positive, this means your parabola will open up. And some of the characteristics of your parabola are that you'll have something called a vertex, which is the main point of the parabola. You'll have a y-intercept. You'll have something called the axis of symmetry, which cuts straight through the middle of the parabola. And then for a parabola, you may have two x-intercepts, you may have one x-intercept, and you may have no x-intercepts. But one thing is for sure, you will always have one y-intercept. Okay, so these are the characteristics of a parabola. And what's cool about the axis of symmetry is that you can reflect points across it because it's symmetric. So if I had, let's say I had a point over here and I wanted to graph another point, then I would use the axis of symmetry to reflect it across and get a point equal distant from that line reflected over. So the axis of symmetry allows you to reflect points. Or they also say you could fold it in half and you would have the lines right on top of each other. So the axis of symmetry allows you to reflect points across it. Okay. And I guess I can get into this too. Why not, since we're here? For a parabola that opens up, your domain will always be all real numbers. And this is because a quadratic function is a polynomial, and the domain of all polynomials is always all real numbers. Okay, and then if we're talking about domain, let's talk about the range. If you have a parabola that opens up, then remember how range goes. Range starts at the smallest y value. Well, domain and range always start at the smallest value and end at the largest value. So if you're dealing with range of a parabola, you're going to start at the y value of your vertex, and you're going to head up towards infinity. This is the domain and range of a parabola that opens up. Okay. And I guess one more thing about parabolas that open up. If your parabola opens up, then you create something called a minimum. And the vertex is called the minimum. So, or a minimum will happen at the vertex. Minimum at y equals k. And I'll show you what k means in a second. But k is the y, k is considered the y value of the vertex. But we'll get into it when we look at the information below. Okay. All right. Now, let's look at a parabola that opens down. If your parabola opens down, this means your leading coefficient of your quadratic function is negative. And if you open down, you'll see that your vertex is now above everything. So your main point's above everything. And you still have one y-intercept. You still have an axis of symmetry. And you may have two x-intercepts. You may have one x-intercept. And you may have no x-intercepts. And what determines that is the actual quadratic function that's given. Okay. All right. Well, with that being said, guess what the domain is for this parabola? It's still all real numbers because it's a quadratic function. The range, well, now our range will start at the smallest value. So these tails are headed towards negative infinity. This means that when we deal with the range, we're going to start at negative infinity, which is the smallest possible y value. And then we're going to come up our parabola and end at the vertex, at the y value of the vertex. Okay. And then for a parabola that opens down, the vertex is considered the highest point of the graph. This means that if you have a high point on a graph, you create something called a maximum. And this maximum will happen at the y value of the vertex. Okay. And those are the characteristics of parabolas that open up and open down. That's the domain and range, minimums, maximums, y-intercept, x-intercepts, axis of symmetry, all that good stuff. Okay, but now let's look at their formulas. So we have seen vertex form already. We were completing the square to put an equation into vertex form. So here's where H and K, the definition of H and K come in. All right, so if you are in vertex form, then you can find the vertex, which is given by the H value and the K value of your vertex form. That's why it's important to put in the vertex form. Once you put it into vertex form, you automatically get the vertex, HK. All right, where H, of course, is the X value, and K, of course, is the Y value. We just don't label it X and Y because we're talking about a certain form, so we want to put a different label on them. Okay. All right, and then next, if you want to find your axis of symmetry, well, this goes hand in hand with your vertex. If you know the H value for your vertex, then you know the value for your line of symmetry. It's just X equals H. So 3 points right there. Okay. And then to find a y-intercept, we've done this many times. If you want to find a y-intercept, you let X equal 0 and you solve for Y. We've done this multiple times. We did this in the beginning of the semester when we were graphing linear equations. So to find a y-intercept, you let X equal 0 and you solve for Y. And then when you look for x-intercepts, you let Y equal 0 or f of X equals 0 and you solve for X. And if you're going to find x-intercepts, well, you can do this by factoring. You can do this by the square root method. You can do this by quadratic formula, or you can do this by completing the square. Everything we've learned so far on how to solve a quadratic equation. Okay. And here's more information on maximums or minimums. A quadratic function has a maximum at the vertex if the leading coefficient is negative. So that would be represented by the second graph above. So if the leading coefficient is negative, then the vertex will become the maximum. And then a quadratic function has a minimum if the leading coefficient is positive, as you see there. If it's positive, then the vertex is considered the minimum point. Okay. Everything I've shown so far. And then range. If there is a maximum, again, we're talking about this graph. If there is a maximum, where here the vertex is the maximum, then the range is all y values less than the maximum. That's what we put right here. All y values less than the maximum. And then if there is a minimum, which we're looking at the first graph, the vertex is the lowest point on the graph. If there's a minimum, then the range is the y values greater than the minimum, greater than or equal to the minimum, which is what we put right there. Y to infinity means all y values greater or headed towards infinity. So they're greater than the y value of the minimum. Whew, man. Okay. And those are all the characteristics of a parabola. So what we're going to be doing is we're going to be given a quadratic function. We're going to put it into vertex form. We're going to find its vertex, find its intercepts, and graph it. And of course, find domain, range, max or mins, whatever it's asking for. But any questions on this page before moving on?
No, sir.
A lot of information, huh?
Yeah.
All right. Oh, and then I skipped this part, but let's say that we have a problem that just says find the vertex, nothing at all, just find the vertex from the standard form given. Well, we can definitely use this formula to do so. So this is another way just to find your vertex, which is going to be kind of helpful for our word problems. So here, to find the h coordinate, you'd put negative b over 2a, which means you'd take the b value and the a value and plug them into that formula. So that'll help you find h. And to find your k value, you would take your h value and plug it in for x. So this is how you would find h and k without having to complete the square. So again, that'll come helpful in checking our work and probably with the word problems. Okay. So let's try some out. All right. First example up. Find the vertex form, the vertex, the intercepts, the max or min, the range, and graph it. Oof, my goodness. So much. Okay, so our first job is to find the vertex form, which means we are going to complete the square. So let's go ahead and handle that first. I'll put this here. I can zoom in, there we go. And the first thing we're gonna do is find the vertex form. And I'm just gonna rewrite this function. F of x equals x squared minus 4x plus 3, where we notice that this is in the perfect form that we need because the leading coefficient is a 1, which is perfect, which means we can move on to completing the square. And we are completing the square on a function. So we're going to say CTS, and we're going to take half of the middle term's coefficient, negative 4 over 2. We're going to square it. We're going to get negative 2 squared, which is going to give me 4. Okay. And then we add and subtract it on the same line. So I'll get x squared minus 4x plus 4 minus 4 plus 3. And then after you complete the square on it, remember that these three terms become factorable. And these last two you will simplify. So we'll get f of x equals x minus 2 times x minus 2, and then negative 4 plus 3 gives me negative 1. Okay. One last cleanup. We're going to rewrite it as x minus 2 squared minus 1. And there you have it. There's your vertex form. Which means if you have your vertex, if you have your vertex form, you can find your vertex. So that's going to be 2. My vertex. My vertex is HK. So remember, we're looking at the form A times X minus H squared plus K. So whenever you are stating the H value, it's always the opposite sign of what's in the parentheses. So when we state this vertex, it says X minus 2. So whenever you state the X value, it's always going to be opposite. So when I state my vertex, it's going to be 2, comma, and the K value will always stay the same. So the K will be -1. There's our vertex. So it's always the opposite sign of what's inside the parentheses. If it's X minus 2, it's going to be a +2. If it's X plus 2, it's going to be a -2. The reason for that is because of something called transformations, if you guys remember any of that. And if not, just always think opposite, just for the X value. The K value always stays the same. Okay, any questions so far before I keep going?
No, sir.
Okay. So we have vertex form, we have the vertex. Next are the intercepts. So that's 3. Intercepts. First thing we'll look for is the X-intercept. I don't have to write it out. X-intercepts, which means you let f of x equal 0. So what we're going to do here is take the vertex form that I have above, x minus 2 squared minus 1, and we're going to set it equal to 0. And we're going to solve for x. So I'm going to add that 1 over. And then to solve for x, we're going to square root both sides. Here we get x minus 2 equal to plus or minus 1. Add the 2 over, and you'll get 2 plus or minus 1, which means that for my x values, for the positive, you'll get x equals 2 plus 1, which gives me 3. For the negative, you'll get x equals 2 minus 1, which gives me 1. So here's my x-intercepts at 3, 0, and 1, 0. Okay, and then for the y-intercept, well, we let x equal 0, and we'll just plug it back in. We'll plug 0 into that vertex form again. So I'll have f of 0 equal to 0 minus 2 squared minus 1. This will give me -2 squared minus 1, which will give me 4 minus 1, which gives me 3. So my y-intercept is at 0, 3. Okay. Almost there. Now we want to know if we have a max or minimum. Well, you can tell without graphing if you have a max or min based on your leading coefficient. Here on the vertex form and the standard form, the leading coefficient is a positive 1. So if you have a positive leading coefficient, remember that means that your graph will open up, creating a minimum. So this means that for 4, I'll put that in purple. 4, we're going to say that a minimum is at y equals, and what is the k value of our vertex?
-1.
There you go. Minimum at y equals -1. Okay.
Is k always y and h always x?
That's it. Yep. So h is x, k is y, but like I said, since it's in a different formula, we label them differently. Okay. All right. So now we need the range and graph. So let's go ahead and graph it first, and then we'll get the range. So let's look at all the points we have, and let's plot them. Fun colors only. Let's see. So my vertex is the first thing I'm going to plot at 2, -1, which is right there. There's my vertex. And then I'm going to plot my x-intercepts at 3, 0 and 1, 0. And then that's 1, 0, 3, 0, good. And then I'll plot my y-intercept at 0, 3. There we go. And now all I have to do is connect my points. I'm going to go up and to the right, and then up and to the left. And there's my parabola. Okay. Which means for step 5 is want the range. And since my parabola opens up, my range will start at the y value of the vertex and head towards infinity. There we go. There's all the pieces. It's definitely a process, right?
Lots of steps.
But once you get that vertex form, everything kind of falls into place after that. And I think when you're graphing these parabolas, it only asks for, I think, 2 points, the vertex and another point, when you put them on my MATLAB. Okay. Let's try another graphing one out. 6. S of x equals -5x squared minus 40x minus 78. We want to do the same things as above. So to start with, is this in perfect form?
No.
No. So I'm going to say 1, vertex form. I'm going to rewrite it. S of x equals -5x squared minus 40x minus 78. And since this is an imperfect form, what number am I going to factor out from just the x terms? Since we want the leading coefficient to be 1, you always factor out the number that's attached to x squared. So here we're going to take out -5, and that'll give me positive x squared plus 5 from 40. That's what, 8x minus 78. We now have the perfect form on the inside right here. That's the perfect form. So we're going to complete the square. And we're going to take half of 8 and square it. This will give me 4 squared, which gives me 16. Okay. And then you're going to get s of x equals -5 times x squared plus 8x plus 16 minus 16 minus 78. So we add and subtract it inside the parentheses. Now remember, this part you will factor. You'll leave the other 16 alone for now. All right, and now here comes my brackets for neatness. X squared plus 8x plus 16 is going to be x plus 4 times x plus 4 minus 16, close bracket. One more cleanup here. S of x equals -5, fancy bracket. X plus 4 squared minus 16. And now take this 5, this -5, and distribute it to both terms. And you'll get S of x equals -5 times x plus 4 squared plus, what's 5 times 16? That's 80 minus 78. And we'll finally get our vertex form of -5 times x plus 4 squared plus 2. Woohoo. All right, good times. Okay. So now, if you have your vertex form, everything else should come easy. Which means 2, what's my vertex going to be? What's the h value here?
-4.
Remember, -4, always opposite. -4, 2. There we go. -4, 2. Oh, what's it? Yes. Okay. Cool. So next, we move on to intercepts. So 3 x-intercept. We let, well, here it's labeled S of x. equals 0. Okay, so we take our vertex form and we set it equal to 0 and we solve for x. Ooh, this is going to be ugly. So you'll move that 2 over to the right and you'll have -5 times x plus 4 squared equal to -2. Then you'll divide by -5. And we'll end up with x plus 4 squared equal to +2/5. Okay. And still working. I'll move this up here. So now, after we do that, you're going to square root both sides, which means we'll get x plus 4 equal to plus or minus the square root of 2/5. Which I'm going to change into a decimal number. Since this is business math, why not? I'm just going to say on my calculator here, square root of 2/5 is 0. Let me do the plus or minus still. Plus or minus 0.63. Okay. Move that 4 over. And we get x equals -4 plus or minus 0.63. And now we have the plus route, which is going to be x equals -4 plus 0.63. And that's, let's see. Oops. -4 plus 0.63. I get -3.37. And then minus route, x equals -4 minus 0.63. I get -4.63. Okay. Here's my x-intercepts, -3.37 and 0, and -4.63 and 0. That's just ugly. Okay. And then we need the y-intercept. Where you let x equals 0. So we'll have s of 0 equal to -5 times 0 plus 4 squared plus 2. Gives me -5 times 4 squared plus 2. Gives me -5 times 16 plus 2. And -5 times 16 plus 2 gives me -78. So my y-intercept is at -78. Okay. So vertex form, vertex, x-intercept, y-intercept. Next is the minimum. And since my leading coefficient is negative, so for 4, if it's negative, we open down, which means that we're going to have a maximum at y equals the y value of my vertex 2. Okay. And then let's go ahead and graph. Oh boy. I'm not going to worry about that y-intercept of -78. I'm just going to plot everything else. So here, my vertex is at -4 and 2. There's my vertex. My x-intercepts are at -3.37. 1, 2, 3.37. And then -4.63. 1, 2, 3, 4. Somewhere around there. Okay. That's all I need are those 3 points. So I just connect and connect. Which means the very last thing we need is the range. And since it opens down, we start at -infinity and we stop at the y value of my vertex, which is 2. Okay, there it is. All the number crunching. All right, any questions on that one?
Nope.
Okay, well, let's keep going. All right, so that's graphing our quadratic functions by completing the square, finding the vertex, x-intercepts, y-intercepts, maximums, minimums, and range. And now let's get into our application problems. Okay. So, all right, for this example, we found that the marketing research department for the company that manufactures and sells memory chips for microcomputers established the following price, demand, and revenue functions. So the price demand function is P of X equals 125 minus 3X. The revenue function is X times 125 minus 3X, where P of X is the wholesale price in dollars at which X million chips can be sold. And R of X is in millions of dollars. Both functions have the domain of 1 million chips to 25 million chips. Graph the revenue function. Okay, let's go Desmos. So first off, let's pull this revenue function down here. Let me scroll down, there we go. So my revenue function is R of X equals X times 125 minus 3X. So I'm just going to distribute that X and get my new revenue function of 125X minus 3X squared. Okay, so all this says is we want to graph it. So to graph this, well, they're giving us the X values already. They're giving us the X values of 1 through 25. So if I'm going to graph this, I'm going to make an XY chart and pick the numbers they're giving us. 1, and I'm going to jump by 5s. 5, 10, 15, 20, 25. Okay. And now here's where good old Desmos is going to come in. I'm going to type in this revenue function, 125X minus 3x squared. I'm going to do my table and type in these numbers: 1, 5, 10, 15, 20, 25. Fill out my chart over here. I get 122, 550, 950, 1200, 1300, and 1250. Okay. There's my values. And now I'm going to plot them on this chart to the right. Okay. Which means that it looks like the highest Y value we go is to 1300. So let me go ahead and fix my dimensions on Desmos. So I'm going to start at, well, for my X values, we're going to start at 1 and go to 25. For my Y values, let's start at 0 and end at 1300. Hey, look at that. That's nice. Okay. So over here, let me just label appropriately. This will be 1. And then I think I can skip, right? 5, 10, 15, 20, 25. And then our highest is 1300. So we can go by 200. Why not? 200, 400, 600, 800, 1000, 12, and 14. Okay. And now just go ahead and follow our XY chart. Fun colors, right? There we go. And at 1, I'm at 122, so that'll be down there somewhere. 5, I'm at 550, somewhere in between there. 10, I'm at 950, somewhere in between there. 15, I'm at 1200 exactly, which is right there. And then 20, I'm at 1300, which is right there. And then 25, I'm at 1250, which is probably around just a little bit there. So here's what we look like. Perfect.
Professor, I was wondering where you got the squared from the revenue or for the revenue function.
It's when I distributed the X.
Oh, it's okay.
You see it?
Yeah. Yes, sir.
Cool. Okay. So that's graphed. Of course, by the help of Desmos, I think on my math lab is just going to say, pick this graph. But all right. Now, the next question says, find the output that will produce the maximum revenue. Find the output that will produce the maximum revenue. So whenever you see these keywords, find the output that will produce maximum revenue, all this means is find the vertex. And we won't do the completing the square this time. We are going to use this little formula here to help us find the vertex a lot faster. The h equals negative b over 2a and k equals f of h. So that's what we're going to use because that's all we're looking for the vertex. We're not looking for vertex form. So that's going to save us a lot of time. Okay, so we want to find the output that will produce the maximum revenue. So once again, we're using the revenue function. So I'm just going to rewrite it here. R of x equals 1. Actually, I'm going to rewrite it with the highest power first. So negative 3x squared plus 125x. Okay. So if we're looking for the vertex, we're going to use this formula. Let's say vertex is going to be given by h equals negative b over 2a, and k is given by r of h. So let's go ahead and find h. And remember, our revenue function is quadratic in form. It's in the form of ax squared plus bx plus c. So here, when I plug in b and a, I'm going to get negative b, which is going to be 125 over 2 times a, which is negative 3. So negative b over 2a, that gives me negative 125 over negative 6. And we want 125 over 6. Actually, I think, well, first off, I'm going to leave it like this, 125 over 6, because I think this is going to be an answer. It doesn't want you to put in decimal number on my math lab. So 125 over 6 is going to be the amount of chips. So this is going to be 125 over 6 million chips. There we go. This is going to help you with your homework. So if we make 125 over 6 million chips, this is going to give us the maximum revenue. So all we have to find is the K value now, which means we take 125 over 6 and plug it into the revenue function. So this means you'll get negative 3 times 125 over 6 squared plus 125 times 125 over 6. And of course, we're going to use Desmos for the win here. That's a lot of fraction math. All right. I already have the revenue function up. So all I have to do is type in here 125 over 6. Sweet. And we get 1302.08. That's it. Let me just verify that that's right. Negative 3 times 125 over 6. Don't need that one. No. That one. Squared plus 125 times 125 over 6. Yep. We are good. Okay. And what this number is considered is the maximum revenue. So what this means is that if we make 125 over 6 million chips, our maximum revenue is going to be $1,302. Oh, sorry. I did B and C together. So the output is 125 6 million chips, and the max revenue, there we go, is $1,302.08. Okay, there we go. So what I should actually put here is find the vertex. Okay, cool. All right. And last part of this question says, what is the wholesale price per chip that produces the maximum revenue? So all we want to do is take our wholesale price, which is the 125 minus 3x above. And what we're going to do is plug in the amount of chips that we're making, which is 125 over 6. So we're going to say at x equals 125 over 6 chips, we're going to get P of 125 over 6. And we're plugging this into that price demand function above. So it's going to be 125 minus 3 times 125 over 6. And if we're making this many chips, let's see, I'll just type this in my calculator. 125 minus 3 times 125 over 6. And you'll get 125 over 2, but this time it actually wants a decimal number round to the nearest dollar. So we're going to get $62.50, but it says round to the nearest dollar. So this means we're going to get $63. So this is the wholesale price per chip that would produce the maximum revenue. Yeah. Fun stuff, right? Produce that. Yes, yes, yes. Okay. All right. Any questions on that page?
No, sir. Happy that it's done.
Happy that it's done. All right. Perfect. All right, last one. Can we chug this out in 14 minutes? Probably not. So let's go ahead and stop here.
That also sounds good.
I think this one's really long. So yeah. So we'll stop here for now.
Sounds good.